All right, I can see the attendees are still building, but we will kick things off for the sake of time. So, welcome again, everyone, to today's webinar, Best Practices for Studying Geospatial Analysis with CARTO and Snowflake Native App. I'm really, really excited to talk about this and to have our speakers today. We have Fawad and Javier. So, Fawad, maybe you could just quickly introduce yourself.
Hi, everyone. Fawad Qureshi. I'm the Global Field CTO at Snowflake, helping customers with advanced analytics use cases, which include geospatial and time series.
Thank you. And Javier.
Yeah, hi, everybody. So I'm Javier de la Torre, and I'm the founder of CARTO. Excited to be here.
Awesome. Thank you both for joining and presenting today. Really appreciate it. So Fawad, let's give our attendees today a bit of an insight into what we're talking about. If you go to the next slide, we have the agenda. So first of all, Fawad's going to kick us off with talking a little bit about geospatial, how everything happens everywhere or somewhere. Then we're going to go through a little bit about our latest announcement around how you can deploy CARTO as a Snowflake native app using container services. And then Javier is going to run through a superb demo to show you all the great things we can do with CARTO. So quick couple of housekeeping things before we get into it. Please feel free to ask any questions in the Q&A, and we'll get to those at the end. And then everyone will receive a copy of the slides after today's presentation. So you'll receive that in the next few days. So with that, Fawad, over to you.
Absolutely. So today we are not just going to talk about geospatial, we are going to show you all of the stuff that we talk about in action as well. So let's, the thing that I always try to remind people is it's kind of obvious, but sometimes people miss this point that everything, every event, every transaction that takes place in the world is taking place somewhere. The focus on the where. And I always say to my clients that if you do not understand the where, you do not analyze the where, you may never understand the why. And that's why a number of organizations are investing quite heavily in the world of geospatial. But for a very long time, the world of geospatial has remained a very big silo in the organization. Every organization has an enterprise data team. Every organization has an enterprise GIS teams, and they often don't talk to each other because of the legacy. Until 1983, GPS was a classified technology only used for military grade stuff. It was offline by design. And that legacy has remained in a lot of the desktop-based GIS tools till today. So what we are talking about is how do you break that silo, bring that data into the realm of the rest of the data so that you can apply those analytics, apply various types of insights, whether it is AI, ML, all types of analytics could be applied on the data to truly understand what's going on inside your business. Where there are various use cases when it comes to geospatial across various different industries. Many of our clients in the insurance space, in the disaster management space, are doing a lot of flooding risk in properties due to disaster, right? So I want to understand what is my at-risk profile for the various properties, various assets that I have under my insurance, or if I'm an emergency response unit, how should I be better prepared for the disaster that is hitting a certain area in my control. So those are the different types of use cases that you can think of, and that involves both processing vector data as well as raster data, combining them together and bringing a lot of insights from those and combining it with the rest of the non-spatial data to see what could be done, what corrective actions that we can do, who are the citizens that are at risk, how can we manage them and build a better recovery plan for them. In the world of telco, right? So we always talk about telcos being the connected hub of the economy, right? So in the modern world, a telco cell tower is a proxy for urban population. So if I want to find out where do I place my cell tower, or do I want to where should I open up my new market areas? So cell towers gives you a good proxy for population. But if I want to place new cell tower, new 5G antennas, I want to analyze where there is decent coverage, where do I have high value customers, what is the the topography of that area, so that I want to make sure that I have the maximum line of sight coverage. And that means that I need to bring in a lot of data from both vector sources as well as raster sources to make sure that the investment that I'm making on those new 5G towers, 5G antennas is giving me the most return on my investment. Another insurance-based use case in the telemetry-based model of car insurance. So I want to offer drivers better insurance, right? So these days, especially in the UK, all the young drivers under the age of 25, their insurance profiles are quite risky. Their insurance premiums are quite high. So a number of those insurance companies are offering them black boxes to be installed inside the car to track their driving behavior and give them better discounted prices on their insurance premium. In order to provide that, what do you want to do is you want to capture that real-time telemetry that is coming out of that car, bring it into the system, and you want to analyze them for better insurance. So you want to make sure that the safer drivers are continue to get that much discounted premium, whereas the riskier, more aggressive drivers are taking on the most of the cost of the premium. So that is only possible by bringing in that telemetry data in real time, combining with the rest of the data, and then you can do a complete customer 360 analysis, and you can build better profiling inside your platforms. You want to do market analysis, whether in this case, if you have a food delivery company like a quick service recovery, where you have various types of restaurants, customers, and riders in there. So you want to make sure that your restaurants have the most optimal deliveries. Where do you need the more riders? You can do a complete market analysis. You can divide them into various types of H3 cells, and you can build much more optimal use of your network and build that inside the platform by combining data from various different sources. A topic that is very, very close to my heart around sustainability, deforestation, and looking after the planet. There's a new regulation that has come out in the EU called EUDR, the EU regulation for deforestation, where the companies and governments need to demonstrate that what they are doing to protect the rainforest around the world. Every year, we are losing the size of Portugal to deforestation. In the last 30 years, we have lost the size of Europe to deforestation in the rainforest. So there is a lot of deforestation going on due to the massive urbanization that is taking place around the world. How can we build that into a holistic solution? What we can do is we can bring in data from the vector sources, but in this case, a lot of the raster data from the satellite imagery to process that data and understand how we can better manage and control that in the ecosystem. And then we've been talking about the geospatial data already in multiple forms. You have got the vector data, you have got the points, you have got polygons, lines, you have got GeoJSONs and the WKTs and the various types of vector information that is available in various different formats. Then you have got the raster data. You've got various types of array data representing models, imageries, and weathers, pollution. All of those are involved, right? So think of TIFFs, GeoTIFFs, cloud optimized GeoTIFFs. These are the types of formats that are coming up in the ecosystem. The mobility data, I mean, it could take form of the other, but we are giving it a separate category because that has a specialized type of information. You can think of the vehicle telemetry, routes, KML files, different types of boats, flights, anything moving over time. You want to track the location of an object over time, and that effectively gives you a pattern of movement across a certain amount of time. And then lastly, if you have seen those heat maps, those what we commonly refer as the LiDARs or the point clouds, you have business models, building models, 3D buildings, so that you can do complete modeling and combine those data into the ecosystem. And keep in mind that all of these data are often used in conjunction with each other. So you may overlay your your vector data onto the raster data to see what is the socioeconomic profile of a certain area based on what are the underlying characteristics of the land that population is living in. So there are various type of augmentation, intersectionality between these formats, and each format has its own type of use cases within the ecosystem. In the ideal ecosystem, you have a singular platform connecting to all of the data, whether it is geospatial, tabular, structured, document, time series data, bringing it all together into a singular platform. And that platform should be able to run all types of analysis into a single query without any kind of resource contention or competition. And all of the users should be able to run it on a single copy of the data. That's where the movement towards open data ecosystem is taking place. There, file formats such as GeoParquet, Rasket, and Iceberg are coming up a lot. And that's another way of bringing down those data silos and keeping the data into an open format, rather than keeping data into proprietary specialized format of one particular GIS tool, which only that tool understands. And then if you want to use it in somewhere else, you convert that data into some other format. So let's put the data into open format so all the ecosystem can understand that data in that environment. As I mentioned earlier, right? So in today, most of the organization, the GIS data is at its own silos for different reasons. And what we want to do, we want to bring it together. We want to combine them together, because there is a lot of value if you can combine that geospatial data with the rest of the data that exists in the system. So that's the ideal state that we want to get to. And when that system is alone, there's a lot of challenges, right? So you have got limited integration, you have got specialized formats that only that tool may understand, but how do I combine it with the rest of the data, right? So how do I combine that geospatial data with my customer data to understand the customer profiles, demographics, and whatnot? And then that restricts accessibility, because that specialized set of GIS tool may only be limited to those set of users. Javier was talking about at Spatial Data Science Conference on how the number of GIS developers in the world is only about 4 million, whereas Python developers are 18 million, SQL developers are 85 million, whereas English speakers are 1.46 billion and 8 billion total population. So we are talking about now Gen AI conversational chatbots on the system. So how do we expose this data to beyond those certain geeks inside the organization? So we need to really democratize access to that geospatial data to much broader audience. And then those systems often have very poor scalability. I was working with a very popular GIS tool, and it connected to a system, and that tool said, I will not connect to a table with more than 250,000 rows, because that tool wanted to bring all of the data into the memory of the laptop that it was operating in, and then you could do. So what you have to do is you have to build data pipelines outside of the tool in some other process, and often it may require in an organization that's a different persona. That analyst needs to work with a data engineer, that data engineer needs to create the pipeline in some other tool, and then build the data and make it into a very slow process for the organization. And that results in a lot of cost inefficiency. Maintaining different GIS infrastructure licenses creates higher TCO, duplicate systems. So that's what we really want to avoid and try to bring it into that singular platform. And this is what we have done with the Snowflake AI Data Cloud. We allow the customers to run various types of workloads, whether it is AI, ML applications, or data engineering or data warehouse, all in one place. And geospatial is part of the data warehouse workload within the Snowflake AI Data Cloud, where you get a fully managed infrastructure with the simplicity, scale, and governance, giving access to more than 10,000 customers through this AI Data Cloud, collaborating with the ecosystem and whatnot. So that means you are able to run any type of analytics on that single copy of the data, whether it is geospatial, AI, ML, and you can even combine them. You want to apply AI on the geospatial data, create Geo AI, Geo ML, and conversational type of workloads on the platform on geo data. That is possible. So in a summary, what's available in in Snowflake, from a geospatial perspective, you've got 2 data types with more than 60 functions each, providing various type of distance, relationship, functionality, all of those. You've got various spatial grids, both tessellation and grid-based operations, so that you can get load and go performance. You can even add faster search and geo joins. You can 10x speed up using search optimization capabilities. Really very low maintenance, load and go performance. You can process billions of rows in a matter of seconds. Points and polygon queries are served quite quickly without any additional indexing requirement. And then you've got native support for H3. You've got additional spatial grid support like S2 quad bins through the CARTO Analytics Toolbox. We've got various spatial data sets, right? So when you want to combine those data sets, so there are 150 plus providers of geo data sets in the Snowflake marketplace, providing a lot of socioeconomic behavior data that you can combine with your rest of the internal data, external data, to do a lot of interesting things. One of that data set is Overture Maps that has been brought to the Snowflake marketplace by CARTO, which provides a global points of interest database of more than 1.3 billion points available for free in the Snowflake marketplace. And lastly, taking it to the next level through the advanced native application inside Snowpark Container Services, where you can run any type of application in the container. You bring the application to the data instead of shipping the data over to the application. And that's what we are going to talk about, how CARTO is now available as a fully managed native app inside the Snowflake platform, reducing the need for setting up the infrastructure, managing it, 2 clicks thing, and you are able to get going readily on that single copy of the data. So I'll hand it over to Javier to take us through those capabilities, and we will see a very nice demo at the end as well. Javier.
Thank you very much, Fawad. I appreciate it. So I'll take it here. Let me actually share my screen too, so we can. Okay, there you go. All right, here we are. So yeah, thank you very much, Fawad. It is a very exciting time. I mean, like I truly believe, we're living now in a time where geospatial data and geospatial technology is converging with the rest of analytics, and Snowflake is really a big part of that, right? I mean, like Snowflake and like how it is enabling to do more spatial analytics on the cloud. It's really going to allow organizations to think about their GIS requirements together with the rest of their analytics requirements. So I like to say that CARTO together with Snowflake are breaking that GIS data silo. So if you move your data to your geospatial data to Snowflake, present it as Snowflake objects, tables, etc., and then you use CARTO on top of it, you can think about how to do GIS in a modern approach. So let me actually start with this. So what is that like CARTO provides, and I'd like them I'll give you a demo later. So at the beginning, I like to say that the most important part is really enabling companies to move their data and to manage their geospatial data on the cloud. The traditional GIS industry has many different file formats, geo packages, save files, like GeoJSONs, and that's only on the vector side. If you think about rasters, there's GeoTIFFs, there's NetCDFs, there's many different geospatial formats out there. What CARTO allows you on the first place is to transform that data and make it available inside Snowflake platform, just as regular tables, right? And that is, and then when you have it in Snowflake, also allows you to manage it, to create indexes, spatial indexes, and things like that. Then once you have your data on the cloud, then it's all around analyzing the data, and we provide a workflows experience where you can drag and drop components, and all of that you will see compiles into SQL that is executed by Snowflake. So it allows you to perform a spatial analysis on top of a Snowflake. Third, you will see some examples later. Also, visualization is very important when it comes to geospatial use cases. You need to see on a map very often the data. And one of the things that like CARTO together with Snowflake can do is that it allows you to visualize very large amounts of data. So if you have a map with 1,000 points or polygons, any BI tool can handle that. But when you go into the millions, like then it becomes much more challenging. And CARTO can handle millions, no, it can handle billions of records on top of a Snowflake by using the streaming capabilities, like between Snowflake and CARTO. So you'll see later that too. Finally, on top of what Fawad was commenting, the future of interaction with a lot of these maps are going to be in the on the usage of AI. So we have our CARTO AI agents that builds on top of a Snowflake Cortex and some of the Snowflake AI capabilities that allows you to essentially talk to the map and allow to have a natural language perform a spatial analysis, democratizing the access to these type of solutions. And finally, we'll not be showing it to you today, but also the possibility to integrate it inside your own applications. So many organizations, they need to create these capabilities and embed it into an internal application or an external application. So all of that is possible with CARTO on top of a Snowflake. So let's get to that. Now, one big difference, or one characteristic that of how CARTO works on Snowflake is that I like to say is that we're truly cloud native. And what we mean by that is that not only we connect to a Snowflake, but CARTO runs on top of a Snowflake. And what we mean by that is, think about if you're doing an analysis like a spatial cluster, typically called like a spatial analysis, something that you're performing. In our case, CARTO, when you design that analysis, will get compiled into SQL or Python that then is sent to a Snowflake to run where the data is in Snowflake platform. That's versus the traditional industry. What they will do is that they will connect to a Snowflake. They will extract the spatial data, run it on their own infrastructure, and then maybe sync it back, right? So CARTO runs directly on Snowflake. So that means that you can liberate, the existing computation that you've done, the scalability of a Snowflake, but also that, you're doing it together with the rest of your data. And that's what we really mean by being cloud native, because you are performing geo where your data is. You're not having to extract your data to perform geo somewhere else. Now, how we do this, it is because CARTO is split in two parts in our product. So on one part, what you will see is more the UI part, is our application, where you design your maps, where you make your analysis, where you talk with the AI. This is what we call the CARTO application. That, in fact, actually is a Kubernetes application that you can run on your own infrastructure in different ways. You will see, right? But that's just the UI that generates the SQL that then connects through a Snowflake API, SQL APIs, and then runs it on Snowflake. And then what we do on the other side is we have a Snowflake Native App, which is a set of UDFs, stored procedures, and other assets inside Snowflake that you install as a native app on your Snowflake account, and that allows you to run much more complement what a Snowflake can do from Geospatial to fully cover all your Geospatial needs, right? So you see a lot of our algorithms and IP actually end up being installed on Snowflake. We don't run it outside, we run it inside your Snowflake. So that's how technically it works. I also want to mention what Fawad pointed out, that there is, for most of the use cases, when you're doing a spatial analysis, you're going to need your own data, where your cell towers are, where your farms, where your cars are moving, all those type of things. But then you're going to need to put them on the context of other data, like demographics, financial, infrastructure, POIs, where your competitors are. So for that, we've curated a set of more than 12,000 geospatial data sets so that you can use it directly on CARTO for your own analysis. And those data sets, we make them available through a Snowflake Marketplace, with the convenience that if you subscribe to any of those data sets, some of them are commercial, some of them are free, they will get updated automatically as we update them. So with the magic of the data cloud that Snowflake provides, essentially you will get access to this data and it will just become just regular tables without you having to ETL or prepare for them. So very useful. And one of the specific data sets that is very exciting, because it's very comprehensive, is Observatory maps. So the Observatory Foundation has curated and is curating a data set called Observatory Maps that is based on OpenStreetMap and other sources, and essentially make, like what I call available the foundational geography data. So you have things like where roads are, where infrastructure is, POIs, like stores, pharmacies, any kind of category on that, or or anything, like around administrative boundaries. So those are kind of like foundational type of data sets that you often need to do a lot of this analysis. And we made all of that available. There's more than 600 million buildings, for example, more than 500 polygons in terms of boundaries. You can see that. I'm going to, I'm sharing here, hopefully my screen, you see, this is the listing of Observatory map buildings. I'm going to be using it in one of the demos later. This is the 600 million buildings. You can just call like subscribe for here and just, like, oh, here's man's listing because I'm the owner, but, like, here's, how you can get access to it and so on. If you look for the marketplace, if you search on marketplace in Snowflake, you can find all those data sets. Pretty useful. Now, let me continue with this. Yeah. Now, when I was talking before about, like the ways that you can deploy the two parts that CARTO provides. So you see there's the application and then the native app, right? So the native app, these UDFs and SDKs that I was talking about, they're always, of course, installed on your Snowflake account. You can just use them directly from there, right? With the native capabilities of Snowflake. But then the application layer, you can either use it in our SaaS. If you go to CARTO.com, you can get an account and start using it, or you can self-host it in your own Kubernetes cluster under your EKS or Cloud Run or whatever Kubernetes cluster you want to run on your cloud. Or this is the exciting new thing that we were mentioning. We just launched CARTO as an application inside Snowpark Container Services. And what this means is that now you can run CARTO application inside your Snowflake in their new container service, and data is never leaving your entire Snowflake, and everything is managed by Snowflake. And that's very, very exciting because not only is very secure, obviously it's everything within your Snowflake environment, but also it's very, very easy to get started. So especially when we work with large enterprises, we find that they will use SaaS as a way to try our product, for example, when using none of their actual data because they cannot really upload it, to a managed service like this. So to be able to try it, normally they have to go and deploy our application and self-host it on their infrastructure, and that can take more or less time depending on their availability of engineers to deploy. Well, deploying inside Snowflake, the right option, it is a matter of, in less than 20 minutes, you have an up and running, and it's just straight away by any Snowflake administrator. So it's a great way to try the entire application, within your secure environment with your own data, and start looking at, how this works. So for that, I do have a video because it's a lot of clicks and I was not going to get it, but I want to show you a little bit, how this works. So you see here, this is the Snowflake marketplace, and what I'm looking at in here is the listing of the CARTO platform. So that CARTO platform, it is this native app, these container apps that I was talking about. Now I've just got requested to be able to use it. You have to request it, and we have to approve it. And once you get it, now you install it. So you see, I just installed CARTO in there, and I have to configure it. And configuration is a process where I have to give permissions to your data, certain kind of things, granting connections to different things, and we just do it through a set of user interfaces that allows you to get this done. So see, in this step, for example, you need to have a CARTO license key. So if you're not in a trial, we'll just give you a license, with all the information about the number of users, etc., and so on. Remember, this is an application where it's everything inside Snowflake. So you just have to we're not calling back in this case, to CARTO. Now we are going here to configure it. So things like, for example, integrating CARTO and Snowflake OAuth. So when you log into CARTO, you are not you're asked, with the same credentials of your own Snowflake, right? And this is important because governance is a very big important thing in here. Because CARTO is built on top of a Snowflake, all the governance in terms of user permissions and all this is maintained within that, which wouldn't be the case in other non-cloud native situations. So we're also installing this in the analytics toolbox. We're creating admin credentials, all those type of configurations. Now I'm just installing it, and now finally, now it's installed, I can go and log in as an administrator. So actually, it's giving me twice to log in, just one, because in Snowflake I have to log in as a Snowflake user, and then even using again a Snowflake users, I am allowing itself to set up an organization. Now in this case, it's the administrator setting up an organization, and I'm here already, and as you can see, well, maybe very little, the URL in here is under Snowflake computing. That's because it is being deployed inside Snowflake. This is not our URL. This is actually a Snowflake, and you have the entire CARTO application, with the capabilities to design maps, to perform workflows that I will show you in a minute. Now, of course, this is a video where we've speed up things a lot, but the majority of the process is just clicking and configuring options. So we think this is an incredible new way of deploying secure enterprise applications, analytics applications that I think Snowflake is doing a great job on simplifying for organizations. So very excited to be part of that. I go to the next slide. Oh, yeah. I think we have still another 10 minutes. So I wanted to use that also to show you some examples, some example visualizations, and some example analysis that you can do once you have CARTO and Snowflake. So just gonna go through a few of them and just then give some time for questions. So this map that you're seeing in here is one of my favorites. I live in New York for 8 years, and what you're seeing in here is a very famous data set of taxi trips. It's open data that essentially shows you locations where there's pickups and where the drop-offs. And in green you can see the pickups, and in pink you see the drop-offs. And it's showcasing, you see most people take their taxis on the avenues, but then they leave them on the streets, right? So I like that map a lot, but I just want to more than just showing you the map. This is a live map coming out of CARTO, and you can see this is an example of where I think we're handling 400 million trips themselves. They're getting aggregated by H3 indexes, is these hexagons that I'm having in here. So this is one of the things that, as Fawad was talking, the fact that you can now use H3 natively on Snowflake makes possible these very fast spatial aggregations, to get insights like this. That's a very exciting type of use case. Another example visualization is in here, is an analysis around accidents, in this case in Paris, sorry, right? And you can see that, there's the cartographic part where I'm seeing again, some aggregations around H3 cells and then individual type of accidents. But you can also see that I have here widgets. And those widgets are connected live to the data set. So as I zoom in, you can see how this the data updates and how I can filter all these things, and that's all connected to the map, regardless of the size of the data. I think that's also a pretty nice experiment to use. Now, but one of the things I want to show you in a few minutes is actually showing you how one of those analyses is actually done, and then how you can visualize it. So I'm going to put it in practice by showcasing you a typical analysis by an insurance company around assessing climate risks. So in this case, you have a lot of buildings in an area, and you want to know what is the risk to different fires or flooding and so on. So we're going to do this. Oh, by the way, this is the actual, let me, just a second. So you can see this is the actual result of my analysis. Let me start with that. So what you see here is an analysis in Texas. And what you can see in different colors is the actual risk level that you get confronted in different parts, right? So the redder, the red is a higher risk, in terms of, like fires and floodings, and yellow is less risk. And as you can see here, can go to any area. So I can go to, let me go to somewhere around here. And as you see, as I zoom in, I can end up seeing every single, in this case, property assets. So in this case, kind of like properties under management that, like this risk is looking at, the value that is actually put it, what is the risk percentile, and so on. So you see how I'm navigating from a very detailed, every single asset that the insurance company might be looking at, and then aggregating it, like at a higher level, so I can see like different areas and so on. I can also call like filter, say I only want to look at, this is property assets, but maybe I'm only looking at infrastructure assets. I also have like some widgets in here, so it just shows me, like the total asset value for all the assets under management. I can see like number of assets by risk percentile, like different high locations, all this. So I'm going to show you how an analysis like this is done. And to do that, I'm going to go to CARTO. And to my interface, sorry, just kind of closing a few tabs. Here I am. So this is the CARTO interface. When you start a CARTO account, you get, this interface again, and the most basic is that you start by connecting your Snowflake account. So I have here, my Snowflake account connected. If you've deployed using the containers app that I showed you before, you don't have to connect because it is already connected, right? And in here I have a few options. So first thing you saw is like this data observatory is all these 12,000 datasets I was talking to you about. Here in Data Explorer, I can explore, the data within my organization, where I can also upload data, for do the data management parts, etc. Right? And then I have here two other parts, which is for making maps. So I will show you in a minute. So this is how this map was done. And then also workflows, where this is where the analysis was done. And I want to show you one of those analyses. Well, the actual analysis that was driven behind this map. Oh, it is in here. It's just opening. This is what we call CARTO workflows. And what you can see in this interface is, let me minimize this. You see, I have here a set of tools that allows me to do different spatial operations. So you have like enrichment by H3 grids, enrich polygons, like I have like also other kind of data wrangling type of like options, or even, like HTTP request, import files, like do spatial joins, all those type of things, get values from raster. So this is a very kind of like set of complete, like set of capabilities in here. Now, my analysis, as I was talking about it, is here I have like historic fires. There's around 800,000 like records of historic fires in Texas. Then I have, on the other hand, I'm looking at hurricanes. So I have like historic fires, historic hurricanes, and I'm using the spatial features, which is a data set provided by CARTO of, essentially where things like, for example, like average annual wind and temperature is. I'm combining all the data and I'm using it to create a score that for every grid, every single cell within Texas, I'm just associating it a risk. So how risk is based on these patterns. And after that, what I'm doing is taking my assets, the properties that I'm managing, the buildings, right? And I'm intersecting, I'm just connecting them, I'm joining them, spatially joining them. So I'm calculating for every of those buildings, every of those points, how much risk there is at its location. And finally, I'm saving that in the table, and you will see how I visualize it. A few key points in here is that you see this entire thing actually compiles into SQL. That's again what I was meaning, like when being cloud native, it means that everything is run by Snowflake. Think of CARTO here as a UI that allows you to do that. And if I allow you, like things like that, I can see things like in a map where I can see, like the different steps for this analysis. I can run it, I can schedule it because, like this might be running every night when there's, like new assets, etc., etc. The result of this, as I said, like going to actually make a map that I have already here created. This is the map that I started with, and this is the designer tool, we call it CARTO Builder, that allows you to see, to add multiple layers, individual asset risk, like Y risk, all this type of data sets. Some of them come from tables, some of them might come from queries directly. So if I click in here, you can see how I am just running Snowflake SQL to kind of create that layer of information. And then I am adding widgets. So all those widgets that I showed you, I just define them in here. You see, I can call like, how they're configured and all those type of things. I can also, of course, customize how these things look like, etc., etc. And I'm not going to have time today, but there's another webinar coming. I can also enable an AI agent. So an AI agent essentially allows you to provide here when you're creating this analysis and this map, to create a prompt and say like, well, this map is around, finding your location, assessing this type of things and so on. And once you activate the CARTO AI agent, then a user that is using this map gets an agent that they can talk to make questions to the map, and then the AI agent will automatically control the interface to zoom into the particular case, perform the analysis, etc. for you. Again, with the goal of democratizing spatial analysis. Great. Well, that was the demo. I think I have a few slides. I want to wrap it up, to have time for questions. So just very quickly, Snowflake has a very great, trial, 30 days free trial that you can go and sign up if you haven't already. And CARTO does too. So the easiest way to try yourself is just going through the trials. But of course, contacting us also, it's a great way to get started. That's, I think, what I had for today. I'm got like 4 minutes for questions. So
Awesome.
Thank you very much.
Thank you, Javier. Appreciate that. And please feel free to ask any questions as we go along here. If we don't get to them today, we will respond over email to you. So please feel free to ask. All right. First question I've got here is, does Snowflake have native support for GeoParquet like BigQuery? Fawad, do you want to take that one?
We don't have it right now, but it is on the roadmap that we want to support. We do have full support for Apache Iceberg and open formats, but we are opening up this as well. And
with that being said, Fawad, if I may add, I mean, I'm one of the authors of GeoParquet. So I can, first of all, GeoParquets are just Parquet files. So that means that you can ingest any existing GeoParquets into Snowflake already with just the regular SQL. And that, Snowflake has of course, very good support for Parquet. And you can load any GeoParquet already on Snowflake. The part that is still missing that they're working on is that where you have to specify, okay, in this column, this is where the geospatial data is. But you can do that also. It's just that you have to run 2 commands instead of 1. So hopefully, Snowflake will get that soon, but it really will not stop you. You can use GeoParquet with Snowflake as of now, just instead of one command with 2 commands. And Snowflake is also, as Fawad is mentioning, is one of the main contributors for adding geo support to Iceberg, which is even the next generation. So very strong push for standards and interoperability.
Cool, and thank you for that. And Pablo, if you've got a question, please just feel free to write in the Q&A. We're unable to unmute people for this session. Next question is, do all enterprise plans have access to CARTO inside Snowflake? Javier, do you want to take that?
Yeah, well, right now, the containers app that I showed you, it is in beta, and we're definitely opening up to anybody that wants to give it a try. Normally, it is just one more of our options of these self-hosted. So, CARTO comes in these 2 flavors. Either we manage it or you manage it. In the case of, Snowflake, in this case, not like you manage it, because in this way it's Snowflake who manages the Kubernetes and everything for you, but we consider also a self-hosted deployment, and that comes as an enterprise account.
Awesome, thanks, Javier. And a question here for you, Fawad. Does running inside Snowflake is sort of like running a Streamlit app in Snowflake?
Effectively, right? It's like a hosted experience. So Streamlit is hosted inside Snowflake, so you can build those kind of application. But this is beyond just the app front end. This is about the entire ecosystem. This is about bringing that application into that Snowflake world of containers. So any type of application that could be containerized can be brought to the Snowflake ecosystem. Last year, we tried out something with CARTO, where CARTO brought in the OSRM, the open source routing machine, which essentially allows you to run complete route time calculation engine inside Snowflake. So it's a very complex non-SQL-like computational framework that brings that comes closer to the data, and now you can do hundreds and thousands of route calculation inside the platform.
Awesome. Thank you. Really appreciate that. Look, we are out of time for today. I just want to say a huge thank you to you, Fawad, and to you, Javier, for presenting today's topic. And also thank you to our audience who have attended and asked questions. Please keep an eye out for the email with all the slides we're going to contain after this. And it's also available on demand. So please feel free to share internally as it will still be available after the fact today. Thanks, everyone. Really appreciate your time and have a great Christmas holidays too. All right, take care now. Bye.